Hi, in this video, I will be showing you problem number 6 to 47. Chapter 6, section 247. Find the volume of a right circular cone with height h and a base radius r. Find the volume of a right circular cone with height h and base radius r. The cone's figure is drawn here, whose height is h and the base radius is r. We have to see what curve or line we have to rotate about the x-axis or y-axis, so we get the shape of a cone, so it is easy for us to determine the volume. So we will place the cone as shown in the figure. So the height is here horizontal, so we will imagine the x and y axis this way. So height of the cone is measured horizontally and the radius is measured vertically. So we are going to rotate the line here about the x-axis, so we get the shape of the cone. So what is the equation of this line? We will call it, let's say, OA. So what is the equation of the line OA? So first we need the slope of the line, which is difference in y coordinates over corresponding difference in x coordinates. So here h is the horizontal distance and r is the vertical distance. So the point A has coordinates h, r. Point O has coordinates 0, 0. So the difference in y, which is r minus 0 divided by h minus 0, or it's r over h. Now this is an equation of a line that passes through the origin. So it is r over h x, which is mx. Then b, the y-intercept is going to be 0. That is r over h x. That's the equation of the line OA. So this is the line we are going to rotate about the x-axis, so we get the shape of a cone. So now we are going to use the disk method in order to find out the volume. The disk method, we will use the volume formula as area of the disk times thickness. A of x is the area of the disk and d of x is the thickness, and then we have to give the bounds for x, which is running from 0 through h, where A of x stands for area of the cross-section disk placed at the distance x. So we will create a disk like that. So that is the area. So area of the disk equal to pi times r square. So pi times, if the horizontal distance is x and then the vertical distance is going to be y. So that is the radius of the disk. Y is the radius of the disk. So it's pi y square. So volume becomes integral 0 through h, area of the disk, A of x dx, but area of the disk is pi y square, but y equal to r over h x. That's r over h x the whole square. So it is pi r square over h square times x square. That is the area of the disk. So we will substitute that in the integral like that. It's pi r square over h square x square dx. If you notice here, everything here, pi r square h square over h square is a constant that can be pulled out of the integral sign. We are left with just x square. We are going to integrate that, which is x cube over 3, which is 0 to h. So it's pi r square over h square times h cube over 3. If you reduce it, it becomes h square goes into h cube, that gives you h. So it becomes 1/3 pi r square times h. Because it's a volume problem, you may want to say its units cube. So this is the formula that we have seen in geometry. The volume of the cone is 1/3 pi radius squared times h. The way we have done this problem is by calculus techniques and by following the disk method. Hope this video